right, class, today we're going to be doing the practice and problem solving for lesson 1-10. Let's begin. I got the odd ones. We got 7 times 10 to the negative 6 power times 7 times 10 to the negative 6 power. Now, if I'm working this out, I take the two numbers in front first, put them, multiply to each other. And then we have 10 to the negative 6 times 10 to the negative 6. We know we can take 7 times 7 and make 4, 9. And 10 times, let's see, when we are multiplying exponents with the same base, we can add them. So this is going to be a negative 12. And now you notice this is 4.9, and that's because the first number in scientific notation has to be between 1 and 10. All right, so that means this is going to be 4.9. We're moving the decimal over 1, which means we have to go ahead and take 1 away. So this is going to be minus 11. You might be thinking, why are we taking it away? Let's think about the number now. This is going to be 49, right? And then it's going to have minus 12 zeros. So let's go ahead and put this in the right perspective. Here we got 49, right? That would be the decimal here, right? Then 12 zeros, so that'd be 1, 2, well, that'd be 12 places, right? 12 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? But when we move this decimal over 1 to make it 4.9, now let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's why it's negative 11. All right, number 8 is yours to do. I have number 9. What is the value of n in the equation? We're looking for the value of n in this equation, okay? We see here we have 1.9 times 10 to the 7th power equals 1 times 10 to the 5th times 1.9 times 10 to the n power. We're trying to find out what that power is. Well, we know that 1 times 1.9 will give us 1.9. And now we remember that if our exponent, or if our base is the same, we can add our exponents when we are multiplying. So if this is 5, I need a number that I can add to 5 that will get to 7, and that's going to be 2. So this means n is going to equal 2. Moving forward to number 11, it says, what is the mass of 30,000 molecules? Okay, express your answer in scientific notation. They said the mass of one molecule of oxygen is 5.3 times 10 to the negative 3 power. Remember, we're taking this, it says, what is the mass of 30,000 molecules? So we're taking this number and multiplying it to 30,000. What is 30,000 in scientific notation? That would be 3 times 10 to the 1, 2, 3, 4 power. So now we're multiplying 3 times 10 to the 4. Three times 3 is 9. And 3 times 15 is, or 3 times 5 is 15, excuse me. And we have 1 decimal place, so it would be here, 15.9. And then we multiply this by, remember, when we're multiplying, we combine these with a negative 23 and a 4, so that's going to be 10 to the negative 19th power. But hold on. Let's remember, we can't have our first number bigger than 10. So we're going to have to move the decimal back 1. When we do that, we're going to have to take away one of these. So one of the powers here. So because it's going backwards, right? This is going to be taking away one of the place movements. So this is now going to be 1.59 times 10 to the negative 18 power. All right. Next, we've got number 13. Find 7.2 times 10 to the negative 8 power over 3 times 10 to the negative 2 power. Write your answer in scientific notation. Okay. Once again, we're going to have to go ahead and treat this like a division problem because it is. We got 7.2 divided by 3, and then we got 10 to the negative 8 divided by 10 to the negative 2. We write this out, we see that we got 7.2, and we're dividing this by 3. Let me put that in a place that we can work a little better. 7.2 divided by 3. Three goes into 7 2 times. Leaving us 1.2. And 3 goes into 12 4 times. Our decimal comes up. And so that's 2.4 now. All right, and now we got to figure out our power of 10. Well, the power of 10 here is, remember, we can say that we have 10 to the negative 8, and we're subtracting, right, a negative 2. But don't forget, we just can't go ahead and combine these two because we're subtracting. So now we have a negative times a negative, and that's going to make a positive. So this turns to 10 to the negative 8 plus 2. Well, negative 8 plus 2 equals 10 to the negative 6. So that tells me I have 2.4 times 10 to the negative 6 power. All right. And let's move on. This is my answer, by the way. And let's go ahead and make sure that we've got a code word for this week. What do I have in front of me? Oh, look at this. I've got some pistachios in front of me. Okay, so if you see the word pistachios on your paper, I know you found the code word. And now I'm going to erase it for those that are just fast forwarding. We're on number 15 now. This says the total consumption of fruit juice in a particular country in 2006 was about 2.28 times 10 to the ninth gallon. Population of that country that year was 3 times 10 to the 8th power. What was the average number of gallons consumed per person in that country in 2006? Well, to do that, I'm going to have to take, let's see. Oh, sorry about that. 2.28 times 10 to the ninth. And we're going to be dividing that by 3 times 10 to the 8th. Well, our first part makes us take 2.28 and divide it by 3. Let's do that over here. 2.28. We'll divide it by 3. I know 3 goes into 2, well, no times, but 3 goes into 22 7 times to make 21. That leaves us with 18 left over. Now I know 3 goes into 18 6 times. So we got, let's see, 0.76. Okay. Let's see here. So we know the first part's going to be 0.76. But no, wait a minute. Remember, our first number has to be between 1 and 10. So we're going to have to move this decimal over 1. All right? Let's check our powers now. This 10 over 9 divided by 10 over 8 is going to be like 10 to the 9 minus 8. And that's 10 to the 1 power, which is 10. So now we have our new number. This is going to be, let's see, 0.76 times 10. Anything times 10 is moving the decimal over 1. So that means this is 7.6. And since we're talking about gallons consumed, 7.6 gallons per person. Okay? All right. And now we have what was the appropriate number of pounds of garbage produced per person in the country in 1 year. And it says here, garbage generated in the country was 6.958 and that's times 10 to the 10th power. And that's going to be divided by the number of people, the population, which was 4.57 times 10 to the 5th. All right, and the first thing we got to do is divide this part here. We got 6.95. We're going to be dividing that by 4.57. Remember our rules for dividing with decimals, we have to move the decimal place over. So we'll have to move this one over twice as well. How many times is 457 going to 695? Well, 1 time. All right. 457. All right. I know that I'll have to borrow one from over here. I'm going to clean this up just a little bit so we can see a little better. I don't want anyone getting too confused with my work because it's messy. 6.958, right? All right, so first 457 goes here. We did move this back 2 spaces, so our decimal is going to be right here. Our first number is 1 because 457 goes into that. We bring down the 8. And then we have to borrow one from over here. That's going to turn this into an 8. 8 minus 5 is 3. And that turns this to a 15. 15 minus 7 is 8. And 6 minus 4 is 2. Now we have to see how many times does 457 go into 2,388. Let's see here. 457. All right. And I'm just going to guess here that 4 times 7 is 28. So I'm wondering if that's going to fit in there, or if I have to multiply this by 5 to get it close to 20. And I'm going to use my calculator here. Kind of take a little shortcut to help me out. All right, first we're going to try multiplying it to 4. 457 times 4. That gives me 1,828. Now I'm going to try to multiply it to 5. Let's see, 457 times 5. And that is going to work, 2285. So we're going to have to take, we're going to have to take 457, multiply it to 5, and that's going to give us 2285. 2285. And that was 5 that we multiplied it to. So we're already at 15, or 1.5. And now we subtract this. This should be 3, and then 0, and then 103. Okay. I'm going to try to just take one more shortcut and just say 6.9 or 6.958 and divide it by 4.57. Wow, we're getting a really big number here. Did it say to round up here? Express your answer in scientific notation. What was the approximate number of pounds in 1 year? Approximate, okay. So I'm thinking 1.5 there, okay? And now let's look at the power of 10. The power of 10 is 10 to the 10th power. And we're minusing 10 to the 5th power. This is going to be equal to 10 to the 5th power. So now we know that this approximately is 1.5 times 10 to the 5th power, right? Oh, wait 1 second. I'm looking more closely at these numbers, and I see this is a 6, not a 5. So this is a 6 here, which means there's a 6 here, which means we have 10 minus 6, and that's not going to be a 5 now. That's going to be a 4, which means this is going to be a 4. So I would get 1.5 times 10 to the 4th power. I mean, if I wanted to keep on estimating, I mean, I could put a 2 there as well, right? I could keep on going. It could be 1.52 times 10 to the times 10 to the 4th power. It all really depends on how detailed you want to get, because I could put a lot of numbers here, but since it goes on forever, it really doesn't pay to do that. I would accept either one of these answers here. And I think that's it for me. That's all of the odds. So it's on you to get the evens down. Don't forget the code word. And have a good night. I'll see you in class.